Mark should be right
Not
up your nose. You're gonna
care.
Hello, my friends.
Mark should be about right.
Learning time.
Getting to that line. Somebody
Is that-
look
is
at
that
it.
the
Can you see
line?
that line?
You can actually move it over a little more.
Yeah,
Where?
More that way.
Little.
a little bit, right? Let go.
Just yeah,
Let
just
us
right
go.
there.
there, right
So
there.
I pretty much have the whole board.
Yeah.
Yeah.
Okay.
Yeah, you've got.
9-8 is about systems of linear and quadratic functions. Okay, so what that means, what's a linear function?
The straight line.
A line. And what's a quadratic?
Curve.
Right, it's a parabola.
Oh, correct.
Okay? Now, let's think about this. When we have a system of functions, whether they're all linear or whatever, what are the solutions of the system? All right. If we have a system of linear equations, okay, or linear functions, so that means we have lines. What's the solution? It's where they cross, right? The same thing goes for a system when we have one linear and one quadratic. It's where the line and the parabola cross. That's the solutions to the system. Okay? So if we think about it, and I have something that looks like this, and I have something that looks like this, what are the possible options for the number of solutions I can have? Or in other words, how many times can I make this line cross this parabola? Twice. So that's the most I can have. And that is going to happen when we have a parabola like that, and then a line that cuts through, it'll cross it twice. What are my other options? Is there a way I can make this line to where it only hits one point on here? How?
Going like straight up and down.
Straight up and down. So if I have something like that, and then I have a line that's like this, is there any other way I can get only one solution? What if I went like this? If I have my parabola like that, and I have a line like this, right? They call that a tangent. It only hits one point. Is there a way where I can have 0 solutions?
The line doesn't even just go.
Okay, if I have a parabola like this, and a line like that, they never touch. So there's no solution to that system. Okay? So that's the idea of what we're talking about here. That's the basis of what we're talking about. Where we're given two things, okay? One of them's a line, one of them's a quadratic. And the idea is that we want to figure out where they meet, or what coordinates satisfy both equations. Okay? There's several ways we can do this. We do this the same way as if we were solving a system of linear equations. Who remembers how to solve a system of linear equations? There's multiple ways to do it. Okay? Ryan said elimination. He also said substitution. What's another way? Well, what did I do?
Graph.
Graph it, okay? So we can graph them and just see the points where they cross, and then check those coordinates to make sure that they work in each or both of the equations. We can use elimination, where we stack them up according to their degree, and then we add or subtract them. Okay? And then we can use substitution, where we solve them both for the same thing and then plug one in for the other. Alright, so let's look at an example here. We'll just do a quick example and then we'll move on. So like I said, this isn't something that's going to be super covered, but I want you to have an idea of it, okay? So let's say we have y equals x squared minus x minus 2 and y equals negative x plus 2. We'll solve this system all three ways, just so you can have an idea. Okay? So the first way is to graph it. So if I go like this, draw my coordinate plane. Okay? I'll graph one of them in orange. So we'll graph that line in orange and we'll graph this parabola in red, just so we can kind of see what's going on. So who remembers how to graph the line? How do we graph that line? Okay, plus 2 means I go up 2 on the y-axis, put a dot, and then I use my slope from there to find my next point, right? So my slope is negative 1, so I go down 1, over 1, down 1, over 1. And then I can go ahead and draw my line. How do we graph a parabola? How do we find the vertex of the parabola? And the axis of symmetry. We remember that? That's like 3 days ago, right? How do we do that, Ryan?
Negative b over
2a. Okay, so what's b? Okay, well, we'll just put them all. A, B, and C. A is 1, B is negative 1, C is negative 2. So I have negative 1 over 2 times 1, which is positive 1 over 2. So I have 1/2, right? So that is my axis of symmetry. And it's also the x value of my vertex, right? So I go to 1/2. Which is right about here. I can put my dotted line. Okay? And then how do I figure out the full coordinates of my vertex? Plug that in for there, right? So I have 1/2 squared minus 1/2 minus 2. 1/2 squared is 1/4. Minus 1/2 minus 2. What's 1/4 minus 1/2? Well, I have to find a common denominator, right? 1/4 minus 2/4 minus 2. 1 minus 2, negative 1/4 minus 2, which is negative 2 1/4. You look confused by now. Okay.
I don't know why you said 1/8.
Alright, so my vertex is at 1/2, negative 2 1/4. So I go over 1/2 and then down 2 1/4. And that right there is my vertex. Okay? So, what do I do now?
Oh, pick number. Pick a
Pick some values, right? So I could plug in 0, and if I plug in 0, I get what?
zero.
If I put 0 in for x, I get negative 2. So 0, negative 2. Now how far did I go over? Just a half, right? The distance from my axis of symmetry over to there is a half. So I can come over this way a half, and I don't have the same value. So if I were to go like that and make this thing, where does it look like it might go through?
That
Right
one?
here?
Yeah.
Which is what, 2?
Yeah.
Okay, so let's try 2, just for the heck of it. So if I plug 2 in, I get 2 squared minus 2 minus 2. Or 4 minus 2 minus 2. 2 minus 2 is 0. So I get 2, 0. So that is one of the points that it goes through. Right? So this side is looking like that. Now, from my axis of symmetry, how far over did I go from here to here? Well, I'm at a half, and I went to 2. So I went over 1 and a half, right? So if I go to the left 1 and a half, I'm going to be on that same spot, or that same y value. So I'll go over my half, and then over my 1, put my dot there. So that's what it's looking like, right? So this is one of my solutions. 2, 0. The other solution is the point over here where they cross. So what I have to do, and this would be easier if we were on a legit coordinate plane here, not my poor drawing, where you could kind of see and then you could start picking values that you think where they cross, plugging them in to see if it indeed does go through both this and this. If it does, that's your other solution. Okay? And if you look on page 596 at the bottom, you can see that when there's a good graph, okay, not squiggly lines and stuff, where's the other value that they both cross? Negative 2, 4. Okay? Negative 2 and 4. Which you can kind of see. I mean, my graph isn't that bad. Okay? So if you plug in negative 2, x squared minus x minus 2, you get negative 2 squared minus negative 2 minus 2. 4 plus 2 minus 2, just 4, right? So negative 2, 4. I know that that goes through this. Then I have to check to make sure that the line goes through it. So I want to plug in negative 2 for x and 4 for y. So I'll say negative, negative 2 plus 2 equals 4. 4 equals, this is a positive, 2 plus 2, 4 equals 4. So it checks, so this point does go through both of these things. Okay? Make sense? All right. So that's the first way we can do it. Graphing, I don't know, it's kind of complicated, and it can be sloppy. And if you don't make a good graph, then you might get something wrong. Okay? But for real easy things, it can be the best method. But let's look at the second way. What was the next way, Sears? X squared minus x minus 2, negative x plus 2. So what do I have to do here? How do we do elimination? Why don't you look on the next page, there's an example. I'll give you an idea. Line them up, right? You remember how to do that now? So what do I have to do?
Just x squared over x squared.
Get x squared over x squared. What if I don't have x squared in both of them?
You have to put 0 x squared. 0 x squared.
You line up y. Put that one on top and subtract bottom one.
So if I have x squared minus x minus 2, this thing I'm going to put minus x plus 2, right? And what do I do? Do I have to put the y's on there?
No.
Yeah. Okay, look at page 597.
Subtract the bottom ones.
Okay? What am I trying to do when I'm doing elimination? I'm trying to get rid of everything except for one thing, right? So if you look at problem 2, they say eliminate y, which will leave us with only x's. Right? So why don't we do that? So in order for me to eliminate the y's, what do I have to do?
Subtract.
I have to subtract. So I'm going to put my big subtraction sign here. Y minus y is 0. X squared minus nothing is x squared. Negative x minus a negative x is what?
No, it's just.
What is minus negative x?
Plus.
It's like plus x.
Oh,
What's
so
negative
zero.
x plus x?
0.
0. Negative 2 minus 2. Negative 4. So what I have is 0 equals x squared minus 4. What is that? Okay? I know what you mean. I know what you're saying. Right? We've got a perfect square here and a perfect square here. The difference of two squares. Which means I can factor this super quick. Right?
Oh,
Signs are different. Square root of this goes here. Square root of this goes here. Okay? What do I do once I factor it? I say x minus 2 equals 0, x plus 2 equals 0. Or x equals negative 2, and x equals positive 2. Now what do? I know the x values of my solutions, right?
You plug it in.
Now I have to plug it back in. Which one do I plug it in?
the top one.
Shouldn't matter, right?
Yeah.
Because what we're looking for is the points or point where these cross. Which means if the x value of 2 and of negative 2 is the points at where they cross, that's going to work for both of them. So I'm going to pick the easier of the two, which would be the line, usually. Okay, in this case, negative x plus 2. So y equals negative x plus 2. All I have to do is plug in both of these values. So here I have y equals negative 2 plus 2. And here I have y equals negative 2 plus 2. This is 0. This is 4. Does that make sense? So I have the ordered pair 2, 0, and negative 2, 4. There's my solutions. And if we look back here, negative 2, 4, 2, 0. Same thing. Okay? What's the third way? Substitution. Can I erase this graph method? Okay. You like substitution? Yes, so do I. It's usually my favorite way to solve. Okay, so this was the elimination. Here's substitution. Okay, I've got y equals x squared minus x minus 2, and y equals negative x plus 2. So what do I need to do first? Well, if I'm using substitution, I need to get both of them equal to the same thing, right? What do you notice about those two? What, Ashley?
They're all equal to y.
They're already both equal to the same thing. They're both equal to y. So if this right here is equal to y, and this right here is equal to y, then this has to be equal to this. Does that make sense? Okay? Or if you want to think about it a different way, I'm going to take this and plug it in for this y. Okay? What do I do once I do my substitution part?
Get the x's on one side.
Right, I get everything on one side and get it equal to 0. Okay, so I'll add an x and subtract a 2. So those cancel, and I have 0 on this side. X squared, negative x plus x is nothing. Minus 2 is minus 4. And now I'm right back here. So I can say x plus 2 times x minus 2 equals 0. Or x equals plus or minus 2. Then I can plug those in just like we did here. And I get the same thing. Okay? So all 3 of the methods work. All 3 of them will be easier depending on what you're given. Okay, in a situation like this, I would say probably use elimination or substitution. Just because substitution, they're both already equal to y, you can do it real quick. And that literally took like 2 seconds. Okay? Elimination here, they're both equal to y, so when we just subtract them, it gets rid of the y's right away, and then you're ready to go. Alright? Graphing, if you have good graph paper, or like on the ECA, when you're taking it and they give you the graph, and all you have to do is click dots and put a line and stuff, then that might not be too rough. Okay? Any questions about that? Alright, let's go ahead and move on. Now, let's look at page 615, 14. Alright? Pythagorean theorem. We should all remember this, right? Is there anybody that does not remember what the Pythagorean theorem is?
We all know Titus.
Okay? What is it, Titus?
A squared plus B squared equals C squared.
Right, a squared plus b squared equals c squared. And when do we use it?
Find the triangle in. Find a side of the triangle.
Okay, not just any triangle, a right triangle. Okay, what's a right triangle? It's a triangle with a right angle. So it might look like this. Might look like this. Maybe like this. Okay, it's just a triangle that has a 90-degree angle in it, a right angle in it. And that right angle is signified by this little box. Okay? And the Pythagorean theorem says a squared plus b squared equals c squared. Alright, where a and b are the shorter sides, and c is the hypotenuse, or the longest side. Okay? Now, to figure out the hypotenuse, if you don't know which one it is, the hypotenuse is always the side that's opposite of the 90-degree angle. Or in other words, the box from the right angle points at the hypotenuse. Okay? Alright, so if we have a triangle, looks like this. Okay? And let's say we have lengths like that. Okay, and I want to figure out what that third length is. I can use the Pythagorean theorem to figure that out. A squared plus b squared equals c squared. So what's a here?
5.
Sure it's not x?
Yeah. So there.
No, it doesn't. Okay? You like 5. Alright, so we'll make a 5. But it doesn't really matter. Okay, that's the point I was making. A and B are the two short sides. Doesn't matter if you make x a or if you make x b, or 5a or 5b. Doesn't matter. Okay, so long as these two short sides are a and b. So we'll say 5 squared plus b, which is x squared, equals, c is the hypotenuse, it's opposite of the 90-degree angle, so it's 13. So we have 13 squared. Then to figure this out, or to figure out what the value of x is, we just use algebra. Okay? 5 squared is 25, plus x squared, what's 13 squared?
169.
Alright, 169.
Good job,
Now,
Brandon.
what do I need to do now if I want to figure out what x equals?
Subtract 25.
Subtract 25. So I get x squared equals 144. Now how do I get x by itself? Square root. And x equals 12 inches.
Nice. You know, I never
Okay?
I know, I never knew how to do this.
like I know how to do a squared plus b squared equals c squared. It's just I never knew which side was which, and I could never do it right.
Yeah,
So you get it now.
Yes.
Okay,
this is
great.
probably the one thing that we did learn at Tuscan. I actually did really well in this.
Okay, so do we understand how to use the Pythagorean theorem? Alright, now, if we look at the bottom of 615, you see 3 highlighted words. There's conditional, hypothesis, and conclusion. Okay? If-then statements, such as, if an animal is a horse, then it has 4 legs. Those kind of statements are called conditional. Okay? Conditional have 2 parts. There is a hypothesis and a conclusion. The hypothesis is the first part after the word if. Okay, so in this case, the hypothesis is an animal is a horse. The conclusion is the part that's after then. So in this case, the conclusion is it has 4 legs. Okay? Everybody understand that? Now, on the next page, you see another highlighted word called converse. Okay? The converse of a conditional simply switches the 2 parts. So if we go back to the thing, the first conditional, if an animal is a horse, then it has 4 legs. The converse of that would be, if it has 4 legs, then it is a horse.
Oh, but that's
Okay?
That's right.
But that's not always true. So, the converse of a conditional is not always true. Okay? Does everyone understand that?
Yeah.
It can be true, but it's not always true. Okay? Now, the converse of the Pythagorean theorem simply says that since a squared plus b squared equals c squared works on right triangles. We know it works, okay? And we know it works on right triangles. It says that if a triangle has 3 side lengths, and when we put them into here, it works out, then that triangle is a right triangle. Does that make sense? I'll say it again. Since this right here works for right triangles when we plug in their side lengths. If we have just 3 random side lengths of a triangle, we can determine whether or not it is a right triangle by plugging the values in here and seeing if it works. If it works out, then yes, it is a right triangle. If not, then it's not. For example, if I have the side lengths 3, 5, and 4, okay, and I want to say, are these sides of a right triangle? Okay, well, to figure this out, I can use the converse of the Pythagorean theorem. In other words, if I take these 3 numbers, these 3 side lengths, and I plug them in to the appropriate spots of that, and it works out, then I know it is a right triangle. So let's try. A squared plus B squared equals C squared. Now, the hypotenuse is always the longest side, right? So C, what would my C be here? 5. So I'll put 5 squared here, and then 3 squared plus 4 squared. It doesn't really matter. So I have 9 plus 16 equals 25. 25 equals 25. This is a right triangle.